Welcome to the Dragon 9 Media Podcast. This podcast is the seventh in a series focused on learning about artificial intelligence. If you enjoy this content, please subscribe and like this channel to help promote it to others. Hello, and welcome to AI Demystified, where we break down the exciting world of artificial intelligence into bite-sized, easy-to-understand pieces. Today, we're diving into a fascinating part of AI that's all about teaching computers to see and understand the world around us. It's called computer vision. You know how we humans use our eyes to see, recognize faces, read books, and navigate the world? Well, imagine trying to teach a computer to do something similar. That's the core idea behind computer vision. It's a field of AI that works on enabling computers and systems to get meaningful information from digital images, videos, and other visual inputs, and then take actions or make recommendations based on that information. Think of it as giving sight and visual understanding to machines. So, how exactly do we get a computer to see? It's not like they have biological eyes. Instead, they use cameras to capture images or video, but a raw image to a computer is just a bunch of tiny dots called pixels, each with a color value. The first step is often to process this raw visual data, maybe by reducing noise. Imagine trying to clear up a fuzzy photograph so you can see things better. This pre-processing helps the computer focus on the important stuff. One of the most basic things we teach computers in computer vision is image classification. This is like teaching a toddler the difference between a cat and a dog. You show them lots of pictures and say cat or dog. Eventually, they learn. Similarly, we train an AI model by feeding it thousands, even millions of labeled images. For example, images labeled cat, dog, car, or even types of scenes like beach or forest. Then, when it sees a new image, it can classify it into one of those categories. Now, let's take it a step further with object detection. It's not enough to just know there's a car in the picture. We want the computer to know where that car is, and if there are multiple cars, where each one is. Object detection identifies and locates one or more objects within an image, usually by drawing bounding boxes around them and labeling each box. Think about a self-driving car. It needs to detect pedestrians, other vehicles, and traffic signs to navigate safely. It's like having superpowered eyes that can pinpoint everything important in a scene. Then there's something called image segmentation. Imagine you have a photo, and instead of just drawing a box around a person, you want to highlight every single pixel that belongs to that person, separating them completely from the background. Semantic segmentation assigns a class label to every pixel in an image. So, in a street scene, all pixels that are part of a car get labeled car, all road pixels get road, and so on. This is super useful in medical imaging, for example, to precisely identify the boundaries of a tumor compared to healthy tissue. It's like a very precise digital coloring book. Computer vision isn't just about still images, it also works with videos. Object tracking is all about following a specific object as it moves through a video. Imagine watching a football game on TV, and the camera automatically follows the ball or a specific player. That's object tracking in action. It's essential for things like traffic monitoring or understanding how an organ moves during a medical scan. Before a computer can do all these fancy things like recognizing objects, it often needs to understand the basic structure of an image. This is where feature and edge detection come in. Edges define the boundaries of objects, like the outline of a person or a car. Features are distinctive points in an image, like corners or unique patterns, that can be reliably found even if the object is viewed from different angles. Think of it like sketching the main outlines and key points of a drawing before you fill in the details. Your phone camera does this all the time to help it focus. And here's a really exciting one: image generation. You've probably seen AI creating brand new images from just a text description. That's computer vision too, working with other AI techniques. You could type a purple cat wearing a wizard hat sitting on the moon, and the AI can generate an image of that. It uses techniques like generative adversarial networks, GANs, or diffusion models. It's like having an artist who can draw anything you can describe. The applications of computer vision are truly everywhere and are transforming industries. In healthcare, it's analyzing medical scans like X-rays and MRIs to help doctors detect diseases like cancer earlier and more accurately. In security and surveillance, facial recognition is used for access control, and systems can monitor for unusual activity. Autonomous vehicles, as we mentioned, rely heavily on it to see and navigate roads, detect other vehicles, pedestrians, and traffic signs. In manufacturing, AI-powered cameras inspect products on assembly lines to find tiny defects much faster than a human eye could. And in retail, it's used for things like automated checkout systems in stores, or even virtual try-on apps where you can see how clothes might look on you without actually trying them on. You might be wondering, how does the computer learn all this? Often, it involves something called artificial neural networks, which are computational models inspired by the structure of the human brain. Specifically, a type called convolutional neural networks, CNNs, have been incredibly successful for computer vision tasks. Think of it like this. You show the network thousands or even millions of labeled pictures, say, pictures of cats. The network adjusts itself a little bit with each picture, learning what features, like pointy ears, whiskers, furry texture, make up a cat. After enough training, it can recognize cats in new pictures it hasn't seen before. This process of learning from data is a core part of machine learning, which works hand in hand with neural networks. So, computer vision is this incredible field that's allowing machines to perceive and interpret our visual world in increasingly sophisticated ways, from helping doctors save lives to making our roads safer and our shopping experiences more convenient. Its impact is already huge and continues to grow. Early systems struggled with real-world complexities, but thanks to advancements in AI, particularly deep learning and powerful neural networks, computers are getting much better at seeing. That's all the time we have for today on AI Demystified. I hope this has given you a clearer picture of what computer vision is all about. Join us next time as we continue to explore the amazing world of artificial intelligence. Thank you for watching. If you enjoyed this content, please subscribe and click the like button to help promote it to others. Our plan is to create many different learning tracks, with podcasts, articles, and other supporting materials to support your learning journey.